Good morning, folks. Good to have you. We're happy that you're here. And we're going to have three programs today. This is the first one. It's going to be presented by John Pierce, WB2 MNF. And John's got more than 50 years as a licensee and enjoys sort of the non-traditional side of things in ham radio, like SDR and satellite and microcomputers, microcontrollers, and things like that. He's also the founder of what we affectionately renamed or borrowed the name of, called Skunk Works. You know, one of the aircraft manufacturers has a very famous Skunk Works. Ours is not so famous, but John is the head of it, and he does a fantastic job. And what you're going to hear about today is just one of the various projects that are going on. John?
Okay, there's your sound sync. We needed a loud noise to sync up all these cameras. Good morning, everyone. Yeah, I think they said they moved the speakers around a little bit so they don't start jumping on us like they usually do. So, good morning, everybody, and thank you for coming out on what looks like it was going to be a rainy morning, but I just saw a little thing pop up on my screen that said rain ending. So the good news is rain is ending. The bad news is I don't know where it thinks we are. So the rain will be ending somewhere. I just don't know whether it's actually going to be here. So what I want to talk to you about is setting up a WinLink HF VHF gateway. We set one of these up at the clubhouse. I'll show you a slide at the end. But if you didn't see the clubhouse when you drove down the driveway, it's there. It's the big building with the brand new sign in front of it that Ron put out there a couple of weeks ago. And you can see the setup there if you'd like, and we can spend some time afterwards to go over it if you'd like. And what I wanted to do is I wanted to show you, number one, what an HF gateway is and how we set ours up, and then some of the things that stumped us, because as I was setting this thing up, there was a fair number of the settings that just didn't seem to work. And as I went back over the documentation, in a lot of cases, what I think I found is some of the stuff was written 4 years ago, and they changed it since then. So they tell you to do this, and you try that, and it doesn't work, and then you try something else. How many people are actually interested in doing one of these as opposed to, okay, so I'll go through the actual settings and some of the stuff. Otherwise, I would have glossed over some of the details and just hit you with the concepts. So I realized about 10 minutes ago I wasn't starting out with anything that actually showed you what a WinLink gateway was. So this is what our station looks like up in the clubhouse. And I'm highlighting now the 2-meter piece of it, and the next slide will highlight the HF piece of it. And I'm going to tell you what all those pieces are. Basically, there's a radio, there's a sound device, and there's a computer for VHF. And then for HF, there's a radio, there's a sound card, there's an antenna tuner, and I'll tell you why there's an antenna tuner, and a computer down at the bottom. So that's what an HF VHF gateway looks like. Why would you set one of these things up? This really kind of, what really set home to me was that WinLink can send emails from a ham call to another ham call. But WinLink can also send emails to an IP address and can receive emails from an IP address. So if I send an email from WB2MNF to john@piercefamily.org, I will get it on my phone, and if I reply, it will come back through WinLink to me. That means that you can do third-party traffic this way. And we're talking about a situation where the internet is down. None of your neighbors have internet, all right? And this is the backup to that. So all of a sudden, you've got your own little personal emergency management communication system for your own little neighborhood and your little street, and you're not coordinated necessarily with Aries or anybody else. This is just something you can do to make this stuff work. So how does it work? There's two ways that a gateway works, basically when the internet is up and when the internet is down. So for our station, when the internet is up, the 2-meter and the 440-meter nodes function independently. All right? They're not talking to each other. There's really no need for it. Station connects on 40. They will station connects on 40 or a station connects on 2, and the gateway will then go out to the internet, fetch mail for them or send mail to them, okay? And it uses the internet as the backbone. So the RF link is basically to the gateway, and the message gets moved on the internet. That's if the internet is up. If the internet is down, RMS Relay, which is a program I'll show you in a moment, will realize that the internet is down, or I can tell it that the internet is down. I'll show you how to do that in a couple of minutes. And it will, no, you don't have to pull a cable. You can just change a parameter. I'll show you that. And on our system, the 40-meter station is going to say, wait a second, the internet is down. We've got a bunch of local users who may have email someplace else. So it's going to initiate connections through a list of 40-meter stations that are out there and have are parameterized to be available for RMS, and it's going to go out to a list of 40-meter stations and say, I'm going to try and connect to you, and if I'm successful, do you have email for any of these guys? Okay? And similarly, if somebody connects on 2 meters and sends an email, the 40-meter station is then going to go online, connect to whoever it can, on 40 meters, and say, I need to send this mail out, and hope that that 40-meter station has a connection to the internet. And if it doesn't, I'll show you what that happens then a couple of slides down the road. So that's kind of the difference there. You know, what happens if the internet is up? What happens if the internet is down? So this is a slide from the WinLink book. It's the only slide that I didn't create, and it kind of shows you what happens. The local users are you down here on the bottom. All right, so that's you at your house or at a shelter or wherever you've set up your WinLink station, and your WinLink station can be your laptop, a sound card, and an HT, which is what we do over in the clubhouse. And the computer doesn't have to be much. Micro Center is selling out a bunch of little laptops for $50 that apparently were designated for educational purposes, and somehow they didn't make it to the students. And I got a couple of them, and I put WinLink up on it, and I hooked it up to a Signal Link, and I hooked it up to my HT, and it works. Okay, so you can have a really nice basic station that's one of these. So, and you can connect on packet. It says on the UHF, VHF, it says packet. It's probably more likely to be VARA right now, and I'll show you what that is. This is an old slide. Or, you know, if you've got a 40-meter station, if you're out in the middle of nowhere and you've got a 40-meter dipole set up and you don't have any 2-meter stations locally, you can connect on 40 meters. So we've got stations connecting on 40 meters. It doesn't matter, okay? It all comes into the gateway, and then it goes out, and the gateway, and then it goes out, and the RMS stations are the gateway, okay? So this is you. This is connecting to W2MMD-3. All right. W2MMD-3 is going to go out to the internet. And it's going to say, okay, WB2MNF has just connected. Is there any email out there for WB2MNF? And those content management servers that are in the cloud someplace, it's going to go say, yeah, there's mail for WB2MNF. It's going to send it down over the internet to the gateway. The internet's going to send it out over 2 meters to me. And that's how it works if the internet is up. If the internet is down, it looks to me like 2 things happen. I'd love to see documentation on this, but this is what I figured out from doing this stuff. All right, so I'm going to send an email to somebody. And it could be a ham, or it could be an IP, it could be an email address. Okay, I'm going to connect to W2MMD. W2MMD is going to go out on an HF gateway and try and connect to somebody who's got a connection to the internet. Because it might just be a local internet outage. In Ohio, the internet might be up, so it's going to connect to some W8 station that's out in Ohio, and that station then can do that connection to the content management servers, and will just send the messages back and forth to us on 40 meters. That's what happens if the internet is up somewhere. What it looks like to me, and this is documented, but I've never actually seen this happen because I haven't been able to create a nationwide internet outage, not that I've ever tried, is Suppose I'm sending a message to W6ABC out in California and there's no internet anywhere. I will connect to W2MMD, which will connect to an HF gateway somewhere. All right, the 40-meter station is going to go out and try and connect to somebody on 40 meters because we only have 40 meters at our gateway. We only have a 40-meter antenna. The station that I'm connecting to will figure out a path to W6ABC, and we'll do that based on propagation forecasts, and it will look up in a table, which I will show you how it creates in a moment, to find out what the message pickup station for W6ABC is. So W6ABC, and every WinLink user ought to do this, has gone into WinLink at one point, and I'll show you this like 2 slides from now, where they've said, here's my message pickup station. Okay, if you have to send mail to me, this is the gateway that you send it to. And that information is broadcast all through all of the WinLink network. So what happens is these HF gateways along the way know that eventually they got to get that message over to W6GAT in California, which is a message pickup station. Then W6ABC is going to connect probably on 2 meters, because that's the way most of us do it, and that's how that message is going to get there. So there's no internet anywhere in there. That's the way it's supposed to work. You need to set up a message pickup station. I didn't want to forget to talk about that, because otherwise it doesn't know where to send the messages for W6ABC, so it won't even try. Okay. So how do you do that? This is in WinLink, and this is a user thing, but if you're a WinLink user, don't skip doing this. In settings, hybrid message parameters, you can see this is me. Settings, hybrid network parameters, and I've set W2MMD as my message pickup station. And I set a couple of others just because I was experimenting. I can't talk to them, but this is where I have to go. And that will go into a database on the content message servers and will get distributed while the internet is up to all the stations in the country, all the stations in the WinLink network. And if the internet is down, that'll happen over HF, automatically in the background. Okay? So that's how every station knows how to route a message to you if the internet is down. But it won't know how to do that unless you do that. So if you're a WinLink user, go home, open up WinLink, and set that setting. Okay? This is how it figures out how to get there. This is a function in RMS Relay, which is one of the programs that I'll show you in a minute, where I could basically say, how are you going to get a message to somebody else? And here I picked a 6Y5 because it was probably at the top of the list and just wanted to pick something that was going to be a couple of hops away. And you can see it would go from W2MMD to KJ4YLO on 40 meters. And it's figured out to try to do that because of the current propagation forecast, which it knows, and it distributes to all of the stations through the internet automatically. Okay? And it's going to send from YLO to KX4Z, again on 40 meters, and then it's going to go from KX4Z out to the 6Y5 on 20 meters, because that's where you got to get to 6Y5 land. Okay? So it actually knows where it's going to try to deliver the message. Okay, it figures that out in advance, and all that information is populated while the internet is up and distributed to all the stations. Okay.
It also knows VAR versus Pacto as well?
Yeah, right, because it knows what modes you're running. You know, we tell it we're running VARA. When we were fooling around with Pactor, we told it we were running Pactor. And it also keeps a list of the accessibility of all of those stations. So you can see this is a list of all the RMSs that are registered, and most of them look like they're not available for one reason or another. But I highlighted the 3, one being W1AW, which we can talk to from here. We can connect to Connecticut on 40 meters, no surprise. Okay, but you can see 3 of these are noted that they're up. And it knows that they're up because it created this list that told us that they were up. So it knows who's up. There's really a lot of intelligence there in the backbone. Okay. So there's 3 programs that are part of the gateway. There's RMS Packet. It's called RMS Packet, but it handles Packet, regular AX25 Packet, and VARA. So there's no RMS VARA or anything. They're both run through RMS Packet. It's just called Packet because it was named before VARA existed. Then there's a program called RMS Tri-Mode, that handles the 40-meter HF stuff. So the HF stuff is dealt with differently than the VHF stuff. One of the reasons being it has to be frequency agile, which I'll talk about in a second. And then there's a program called RMS Relay that sits on top of them that manages all this other stuff. It handles the propagation, it handles the routing, it handles whether the internet is down. I think that's where it stores messages for local users, okay? Because it will store messages for local users. I'll show that in a minute. So this is what the desktop looks like on our gateway. You can see RMS Relay sitting up there in the top. You can see RMS Tri-Mode is over there on that side. That's the HF side. And you can see RMS Packet is over here. And WQKBF has just connected to it. So this is the last connection that came in there. Carl came in and either sent or received a message. And because the internet was up, it went over a telnet connection, which is an internet connection, a wired internet connection, and grabbed whatever email he was reading or sent whatever email he was sending. Okay? So that's what the desktop looks like. There's a concept called local users that I need to talk about because the RMS Relay, as far as I can tell, will store messages for local users if the internet is down, okay? And it will poll for messages for local users if the internet is down. So how do you become a local user? All right, well, you become a local user by connecting to the gateway. And you can see it up in the top. This is, again, in RMS Relay, one of the pull downs in RMS Relay. There's a clicker for automatically add packet and telnet users. So if you connect, these are all guys who've connected on the 2-meter gateway or the 40-meter gateway to W2MMD-3. So that's how it knows who your local users are and who it should go gather mail for, all right? So this is the main menu for RMS Relay. I'm going to point out a couple of things on here for anybody that actually wants to set this up. You're putting in your call sign, you're putting in your grid square. Most of this stuff is pretty basic. You do need to register as a gateway. You have to email the guy who handles gateways and say, I'm going to be a gateway, and I'm going to be up all the time. They want gateway stations to be up 24/7, so you've got a dedicated station that's going to be up. By the way, you can be just a 2-meter gateway, which a lot of people are. You don't have to have the HF piece of it. You can just set up a 2-meter station, and the back end of it is the internet, and as long as the internet's up, you've got a gateway for your for all your local users. So this one's pretty easy. These are the ones that were kind of funky. One of the documents that I've read early said that this needs to be this. It's not. It doesn't work. It needs to be with the one that I've got checked. The second one is pretty obvious. Operate as a node in the WinLink network. Yeah, that's what you want to do. That's the whole idea. The third one is enable automatic operation. So yeah, you do want it to automatically handle messages and stuff like that, but maybe you don't. Maybe you're testing or something, but you know, that's the whole idea, is for you to be able to do things automatically. And then the one down in the bottom, this is why you don't have to pull a cable out. Because you can check that box to say simulate internet outage, and the RMS Relay will say, okay, there's no internet. I've got to go into my backup mode. The other thing that I missed, which was checking this right here. Right? If you don't do that, it doesn't know you're running VARA, which means it won't do anything with VARA. So I forgot to do that, and it didn't work for a while, and then I went back and read the messages, the docs again, and figured out that it would work. The other thing you do in Relay is you set up what bands you're going to work. And here we're only working on 40 meters because we only have a 40-meter antenna. We've got a long wire, and when we tried to load it up on 80 meters, it knocked the Wi-Fi out in the clubhouse. The coffee went sour, and it started playing Bohemian Rhapsody on the stereo. So we knew that it was setting up so much RF in the clubhouse that we couldn't use 80 meters. We have to stick with 40 meters. So you're basically saying, I'm on 40 meters. So it knows you can only use 40 meters, you can only be reached on 40 meters, and you can only go out on 40 meters, okay? And that frequency range is pretty critical because that's the only area in the band where you can set up your station with the bandwidth, the parameters that you've set up to transmit with, and not slop out of the bands. So that frequency is pretty critical, and you're going to set that in another parameter a little bit further down. So that was one I had to figure out. You know, if you don't do that, it's going to try and transmit on 20 meters when you don't have a 20-meter antenna, and you'll have the same problem with Queen that we did. This is another set of parameters. Enable forwarding to a CMS. Yeah, if you don't forward to a CMS, your messages are never going to go out anywhere. Enable automatic forwarding, yes. Get incoming mail for local users. All right, so that's basically saying, I want the mail from my local users to be on my local station, as opposed to having to go out to the internet and get mail for local users. So, you know, if you're a local user, hopefully your mail is on the station you're connecting to, because if the internet is down, it might not be there. All right, so this is basically telling RMS Relay, whose mail should I go get? And I showed you a couple slides ago how you become a local user, so those things kind of work together. Hold messages for local user, yeah. And enable automatic polling for new messages, yeah, you want to do that too. And then this box down there with a red line there is how I can force it to go out for mail. So if I want to test an internet outage, those are the two parameters. Okay. The first thing I'm going to do is I'm going to go over here. I'm going to check simulate internet outage. Then I'm going to come over here and say force a check, because otherwise it's going to wait for an hour. Okay, because we've got a parameter here saying wait for an hour. All right, but if I'm testing, I want it to go right now. See if this works. So this is an actual test. We're not running this live, but this is a screenshot. Okay, so I clicked off simulated internet outage. Came over here, force a check. Do you really want to do this? Okay, because there's no internet. You really want it to go out and run an HF forwarding. This is going to take a couple of minutes, so I'll try and fill it in. So it automatically popped up an HF forwarding session. I got to be able to read my screen now. And it's initiating a call to AJ4FW on 7103.6. So the HF stations are not all on the same frequency. They're on different frequencies, and there's a table that WinLink RMS maintains in the background of what frequencies all these stations are on. And so it knows through the propagation forecasts that this station is the most likely station for me to be able to connect to, and it tells it will tell RMS Tri-Mode, which is the program that runs HF, set your frequency through cat control, which you've got to have set up on 40 meters to this frequency, and go out and try and initiate a connection to that station. Okay. And it was not successful, and it's now going on to K1EHC on 7103.8, which is a different frequency. So one of the things that you've got to do in your HF station is you've got to have cat control. Okay, you've got to be able to let the computer change the frequencies that it's transmitting and receiving on. And that's one of the reasons why we have an automatic tuner in there too, because with a long wire, the resonant frequency of that antenna can vary a little bit depending on what frequency on 40 meters we're trying to connect to. So this is going to go through, I think, a couple of stations, and it will actually connect, because I had to run this 3 or 4 times when it didn't connect and then re-record it, because you don't want to see one where it doesn't. But you can see it actually picking different stations, different frequencies, and we ain't doing anything. It's doing this automatically, and based on the time of day and the propagation forecasts and who we failed with last time, it will pick the stations it wants to try to connect to. So if you keep trying and keep trying and keep trying one station, it's going to lock it out locally, saying, look, don't try this guy, you're just wasting your time. And that list will eventually get cleared sooner or later, and it'll try them again. I've noticed each time it does this, it tries to connect to different stations.
John,
Yeah.
so as it runs through this, trying to connect to different stations, right? It goes through the list, doesn't hit any of the stations for whatever reason, right?
It'll just stop and try later.
So it'll time out, use the timer that's set to go again later.
Yeah, and
If it's an hour, it'll go back in an hour.
I think I've never sat around that long to wait because I don't have that much patience.
I would have thought you would have sweet
But-
that time.
Yeah. I mean, I've plenty of times because of our suboptimal setup up there, I've seen it not connect to anything. And like I said, it happened 3 times when I was trying to put together this recording, and I had to go back and do another screen recording of it. Okay.
A lot of those features do sound like bells and whistles they have on the RMS reader.
Okay. So now I got a connection. You can see connected, popped up over there. And again, this is 40 meters. This is VARA HF, by the way. Okay, this is the 2 main transmission protocols are VARA HF and PACTOR. PACTOR was the one that was out there for, before VARA HF came up. And PACTOR works great if you've got $1,500 to spend on a PACTOR modem. Okay. We actually have one, and I tried it, and I had some difficulty making it work. And so when I got VARA working, I ditched PACTOR, and the PACTOR modem sitting in a box that we'll do something with at some point. So it's now going out. See this? Call numbers, and stuff like that. What that's doing is polling for local users. So there's a list of all the call signs of the local users, and the number is the password, an encoded password for that user. Every user in WinLink has a password so that nobody else can get your mail. Okay, and when you sign into WinLink, you put in your password. Well, if it's polling for mail for you, it ought to be able to authenticate, so that's how it does it. So it has now gone out and polled for mail for any of the local users, and is it done? Yeah, it's disconnected. Okay. And the session that was running up top is now gone, and it's done. That's what happens when there's an internet outage. Okay? It just automatically went online. It would go automatically. I forced it, but it would automatically go online. Keep trying to 40 meters, various stations. When it finds one, it'll poll for any local mail. There apparently wasn't any. There wasn't any because the internet's up. In other words, it got delivered, right? But if there had been mail, it would have come through, and that mail then for the local users would be residing in an RMS relay database on our computer up there for WB2, MNF2, and 2 and 3 ASU, any of these guys to log in to get the mail. Okay. So this is what the tri-mode interface looks like. So this is the one of the 3 programs that handles HF, right? And there's a couple of settings in this. Most of them are pretty basic. Needs a grid square. The one that I've got highlighted here, enable connections through RMS relay. If you don't do that, RMS relay doesn't know you got an HF station and won't try to use it, right? So you got to click that on, or you're running an autonomous 40-meter station that doesn't talk to anything else on that box. Okay? This is the setting for where are you listening, okay? Because if someone's going to try to connect to you, they need to know where to get you. And in this case, this is what frequency you're listening on. And this is really critical, and I haven't taken the time to really understand it well, because there's a very limited number of frequencies where you can plop, and depending on whether you're running the wide or narrow version of VARA, you've got to make sure your band edges are within the ham band edges, and they're not slopping over out of anything else. And I just screwed around with this till I got it right, and it stopped sending me error messages. Okay, but you guys who are smarter than I am probably can figure this stuff out a lot better than I can. So basically, we're sitting on 7101.5, running VARA wide, which means we have a licensed copy of VARA. Yes, we do. From 24 hours a day, from 0 to 2300. And I pointed out the fact that, yeah, you got to check off the fact you're running VARA. That's how they know you're running VARA, and they'll try and connect to you on PACTOR or something like that. So that's one of the other configurations that you just got to make sure you get right. Radio settings, again, this is the HF side, so we're talking to FT 857. And the thing that screwed me up on this for a while was that we didn't have it set to USB digital instead of USB. And what was happening is in the USB setting on this radio, you don't get push to talk unless you push the mic button, regardless of what else you're sending in. So when we set it to USB digital, it would transmit in. When we set it to USB, we didn't, and just something that I wish I'd thought about before John Zaruba pointed it out to me when we figured out that it wasn't working. This is the VARA setup. It's pretty basic. The only thing that's you have to figure out is how are you going to get push to talk. And in our setup, we're using cat control for push to talk because we've already got cat set up. But we could use a serial port or Vox or something like that. Cat's going to be a lot better than that. And there's a log file you can use, and I won't spend a lot of time with this, but if you're trying to debug something and figure out what it's been doing, you can open up the log file from one of the log file settings on the menu. And this is the packet interface. So this is the third program, and this is the VHF side of it. All right. And here, different connection. You can see we're on Rust. W2LJR was connected most recently here. Again, pretty basic setups, but another one that I missed, which was use RMS relay. If you don't set that, you have an autonomous 2-meter station that's not connected to anything else and won't forward it, won't do any of the stuff I just told you that it would do. And the reason I've got that highlighted, of course, is I missed that for 2 days and then had to go back and figure out how to make it work again. So on our VHF station, we're running 2 protocols. We're running VARA and we're running IX25 packet, which I didn't realize you could do until I actually, W2KBF actually said, no, you can do it, dumbass, and we figured out how to actually make it work. So here we had to configure the packet TNC, and this is the way you configure the packet TNC. And we're using, for the packet encoder, we're using sound modem, which I'll show you on the next slide. So this is basically the setup that where you would set up in RMS packet to talk to the sound modem for the AX25 packet side. Most of this is pretty basic. The only thing that was tricky at all was, and this is in the documentation, KISS ACK mode, TCP 9600 baud. And then this is the VARA setup. And again, this is all pretty basic. The only real setting there is the channel width for wide. We do have a VARA license, so we can use wide channel width, which makes it go a little bit faster. Although narrow goes pretty damn fast, as I'll show you. Yeah.
I only use VARA occasionally, and I have it in free. 5 emails takes about 12 minutes. What do you see with the license code?
It depends on how close you are. I mean, I'll show you a couple of examples where, admittedly, I was sitting at the desk in the clubhouse talking to the station that was 5 feet away, and we were running about 19 kilobits. So that was fast. Most of our testing has been really close, so I can't really tell how much faster it would go in wide mode. But it's really signal strength dependent. I mean, you can go from 500 BPS to thousands, depending on signal strength, because it'll change automatically. So, does that answer your question? Probably as best as I can answer it.
Question, is it worth paying the money at the license? For somebody who uses it now?
The other thing that the VARA license gives you is the ability to digipeat. And if you're in a hole someplace and you need a digipeater to get to, that's worth it. Otherwise, probably not. You can have a functional station without it. Okay. So this is sound modem, and if you've worked AX25 packet back in the day when KC210 and I were setting up relay stations back in Medford in the 1980s, this is what the packet data transmission looked like. I won't spend time with this because this is not a session on packet, but I was doing a slide session 2 days ago where I was, and so I put this slide in and we talked about it. This is the VARA FM interface. If you've worked with VARA, you're familiar with it. You can see it's showing a connection down there from MMD to KBF10, which is another BBS. And you can see it's 500 BPS. But this is the other way it can go. Okay, again, this was a couple of days ago from the desktop to a radio that's 10 feet away, and we're running almost 17,000 BPS. So that's fast. Now, we were wide here, so I'm not sure whether we're in wide or not, but I think we've seen the same thing with narrow. So when you've got a good signal, it is fast. So how do you set these things up? I'm going to show you how data gets in and then how data gets out. So for VARA HF and VARA FM, they both have this setup screen. You're putting in your registration key for VARA if you've got one, and wide or narrow if it's narrow, if you're not registered, you don't use narrow. And my point here is that the program that's creating the data going into VARA, which in this case is WinLink, how's it getting the data in? It's getting data into this program through a TCP port on port 8301. So that's how the data is getting into VARA. How's it getting out? Okay. Well, this is the sound card setting, and in this case we use a master's communication sound card. How much time I got? Which I'll show you a picture of and some details on later. And we basically set up the outputs to the sound card in this screen. So that's getting in and out. The HF, VARA HF is a little bit different. You still have the in and out, but you also have an option on this screen to set your output level based on the ALC settings. So you can basically click the tune button and drag the drive level up and down until your ALC has the proper setting, and then change it. So that's on there's no comparable setting for that on VARA VHF. VARA VHF also, if you've used it, has the options for ping to another station and the auto tune for another station, and there's no similar option for that on HF. This is the settings for sound modem. So you're coming in through a KISS port on port 8100 down below, and you're going out to the sound device that you specify up above. And if you noted, the sound devices are the same. And I didn't know when we first set things up that you could have two programs simultaneously talking to the same sound device. But you can. Okay, so both of these programs are talking to the same sound card, which are talking to the same radio. Okay, so when you come in, if you come in on packet, it comes in through that ICOM radio to the master communication sound card, feeding both of these programs. And VARA says, I don't know what that is. But sound modem says, oh, I know what packet is. It'll decode it, and it'll send it up into RMS relay. And the same thing happens if you come in through VARA. It's going to come in through the same antenna, same radio, same USB cable, into the same demodulator. The modulated signal will get fed into both programs. Sound modem says, and VARA says, oh, I know what you are, and it'll work that way. So that's how we get both of these programs running. And it was a mental block that I had that you couldn't have two devices on the same audio ports, which was wrong. Okay. The other thing I'll point out here is there's if you're working with sound modem and you want to go outside of the WinLink world and just connect to a BBS, like the KD2LNB, John, BBS that John Zaruba put up on a 160-foot tower over in Glassboro. You want to connect and do AX25 packet for that, there's a program called EasyTerm, which is made by the same guys who developed Sound Modem, and it's just a terminal program. But it comes through port 8000. And again, a mistake that I made is I didn't have that checked the first time. And so when it's trying to come in through port 8000 and I don't have the Sound Modem set up to listen to it, it didn't work. And I had to go back and realize that and go back and change it. So for you guys who ever want to try that, just remember that the port that the terminal program is going to use is different from the port that the KISS interface uses, and you got to have them both turned on. So there's a couple of ways that you can, a couple of different modems, sound cards that you can use, and I'll talk to you about both of them. But you're probably familiar with these. This is a Signal Link. People that have run FT8 are using Signal Links, or if your radio doesn't automatically have a sound card interface, you're probably familiar with the Signal Link. It creates the push-to-talk signal through Vox. You got nice knobs on the front of it for your audio controls, which the next one I'm going to show you does not have. That's why I'm pointing them out here. The only downside to these, well, there's two, is that it's an RJ45 output, which isn't the easiest connector to make. And so you really, the easiest thing to do when you're running with a Signal Link is order the cable that has an RJ45 on one hand and your radio's cables on the other hand. So I got a whole box full of these things that I had to buy from Signal Link because I don't like soldering stuff. There's you know, a different cable for each different type of radio. Okay. The other thing tricky about these is there were two versions of these things. There's a version that has the red transformers and the version that has transformers that aren't red. I forget what color they are. The red audio transformers apparently don't have the bandwidth to go VARA wide. And so they don't work with VARA wide, which matters if you're running VARA wide. You'd have to have the more recent Signal Link, or if you've got the old one, that's why VARA wide isn't working. The other option, which we kind of like a little better, is the Masters Communications box. They're DRA whatever. We have a DRA 50 down at the clubhouse. This is a DRA 34. It's another USB sound card. It creates the push-to-talk signal using a different setup than the Signal Link does. So if you're working in VARA, there's a different push-to-talk setting if you're using the Masters Communications box. And the Masters Communications documentation will tell you how to do that. The audio controls are pots on the board. They're not little knobs on the front. There is no front. Okay, this is a closed box. But, you know, once you set them, they're set. And the thing I like about this is that you can order it with two different outputs. That's one of the reasons there are different models. It can either come with a DB9 connector and you're soldering whatever you need to solder, but the other connector it'll come with is a 6-pin DIN that's the same as the 6-pin DIN for the digital input on a lot of radios out there. A lot of radios have a 6-pin digital input, and this thing's got that as the output. And it comes with a 6-pin DIN to DIN cable. And this is what we're running up in the clubhouse. So we simply took this thing, plug one end of the cable into this, plug the other end into the radio, and we're done. Okay? And the 6-pin DINs have two different audio outputs, one for 9600 baud and one for 1200 baud. You need to use a 9600 baud output if you're running wide. And one of the jumpers in here chooses which line you're using. So that's how it handles that. There's a jumper that will choose either the 1200 baud or the 9600 baud setting for that. We like, and it's a little cheaper too. You can actually buy it as a kit. You can buy it assembled without the box, or we bought the 3D printed box. It's obviously a 3D printed box, and it just fits all together. I'm not buying any more Signal Links. I'm just going to buy these things. So again, this is what the station looks like. Hopefully I've described the components a little bit better. Again, it's an IC880H. The antenna we're using, if you were here last year, you remember that the tornado blew down our VHF tower and our HF tower. As of yesterday, the new HF tower is up with an antenna on the top of it. Thank you to all of you who contributed and to letting us buy that stuff. We got it up yesterday. Take a look on the way out as you drive down the driveway, and that's up. This is a tri-band vertical on the VHF tower, which is still bent over halfway, so it's only about 50 feet up in the air. That's what the Masters Communications box looks like. It's just a black 3D printed box. The computer is a $125 Windows PC. It's $125 because from what I understand, Microsoft does not charge a licensing fee when the CPU is an Atom processor. So that's why they can sell it that cheap. And it is barely adequate. It will run fine, but it will slow down considerably when RMS relay has to go calculate propagation and stuff like that. And we're also finding that sound modem is stopping for some reason, and we don't know why. Thanks, Ron. I wish we had a little more power. We're just not willing to spend $400 or $500 to put a more powerful computer on there. I did try one of those cheap $50 computers that Micro Center is selling. I spent a morning configuring that thing, hooked it up, and it was worse than the computer that we had. So obviously we took that out, and we need to go with something else. So that's the VHF station. The HF station, the ASO has its own sound card. That's up there. And that connects both the sound card and the CAT control to the ASO radio. So the input to that is both CAT and sound go into that box. And then there's the 857. Again, it needs to be frequency agile. The tuner is down below, and the computer is the same. So hopefully you can come up. If you're on your way out of the Hamfest, and you're on your way out of the Hamfest around 12 o'clock, come on up and take a look. The clubhouse is right up the hill there. You can go see it. We'd love for you to come in and see the results of some of the work that we've done, particularly the grounding project that Ron is going to talk about in the third presentation. You can come see how that was done. Unfortunately, our VHF room is under construction, but there's some other stuff. And if you have questions about the WinLink station, that'd be a good time. You said I had 5 minutes? Okay. So any questions? If not, I'll give you 5 minutes back. Yeah.
When you pull down the local email from the network, is it still out there, or is it deleted once it's on?
Good question. I don't know. I'll bet you that it's still out there, because supposing you're traveling and you're not at your home PBS and you want to get your email, and you log into a CMS that's someplace else, I'll bet you it's still out there, but I can't confirm it. I don't know. Okay. Anybody else? All right, thank you.